Hello and welcome to Module 12.2, Representing Data. Our objective for today, I can represent sets of data by using dot plots, and I can determine whether discrete or continuous graphical representations are appropriate, and represent sets of data by using bar graphs or histograms. So we're going to continue our vocab palooza with some new vocabulary for this unit. First of all, we have a dot plot. A dot plot is a diagram that shows the frequency of data on a number line. So we have a number line and we're going to indicate frequency above it. It's usually in the form of like dots. It could be X's, graphical representations, something like that. But it's going to be along a number line and you have it represented in stacks above it. The next vocab term we have is a bar graph. This is a graphical display that compares categories of data using bars of different heights. It is used when the data is discrete and there is a space between each of the bars. So discrete data means they are individual, distinct things. They are not a continuous spectrum that you're working with. Frequency is the number of data values in an interval. A frequency table is going to group those data values into intervals, and it shows the frequency for each interval. The intervals do not overlap, they do not have gaps, and they are usually of equal size or thereabouts. A histogram is a graph that can display data from a frequency table. It's going to look like a bar graph, but it's actually slightly different because since it is a range of values, it is going to butt up against it. So your bars are going to be against each other. There's no gaps in between them unless there's an interval that doesn't have any data to represent. And then lastly, we have a cumulative frequency table. And the word cumulative means we are adding it all together. So it shows the number of data values that lie in or below a given interval. So not line, but lie in or below a given interval. So let's take a look at some dot plots. And what I've already done on my notes is I have put these numbers in numerical order. And you should as well. So we have 9, 11, 11, 12, 12, 12, 13, 13, 13, 14, 15, 15, 15, 15, 15. And so now we make a number line. And on the number line, I'm going to put in some values. So 9, 10, 11, 12, 13, 14, 15. And now I'm going to make a mark for how many times that value comes up in our sample. So we have 1, 9. There are no 10s, so I'm not going to put anything in the 10 column. 11, there are 2 11s. We have 3 12s, 1, 2, 3. We have 1, 2, 3 13s. We have 1 14, and I have 1, 2, 3, 4, 5 15s. So there you go. That is a dot plot for the data that we have given above there. So letter B says we have the data shows internet users from Middle Eastern countries as a percentage of their total population. Represent the data as a dot plot. So now, given that we have, well, I've already put it in numerical order for us, but given that we are given a specific scenario, I need to title this graph. So I'm going to say internet usage from Middle Eastern countries. So these would be countries in for example, like Iran, Iraq, Saudi Arabia, Israel, Lebanon, Jordan. These are all considered to be the Middle East. Kuwait, Saudi Arabia, I think I said, Dubai, the United Arab Emirates, places like that. So in this case, we've got a lot of decimals. And it is unlikely that you are going to get something that is going to, if you did a dot plot for every single one of these values, then it's going to be a mess because we're going from 22 to 96. So what we're going to do is we're going to do ranges. So I'm going to say my first range is going to be 20 through 29.9, 30 through 39.9, 40 through 49.9, 50, and we get the idea, 60, 70, 80, and 90. All right, so that is going to give us our values. So we're going to have that, and now we need to start plotting our points. We have all our data up above, and we just now need to say what falls into the range of 20 to 29.99. And so we're going to have two values that are going to fall into that range. In the 30 to 39, we've got one value. 40 to 49, there are none. 57 or 50 to 59, we have one. 60 to 69, we've got one, two values. 70 to 79, we have one, two, three values. 80 to 89, we have one, two values. And 90 to 99 is one, two, three values. Okay, so there we go. We've got our ranges, we've got a title for our graph. We are good to go. All right, take a look at the next page. You go ahead and do these two problems on your own, and then check your work against mine. So for letter C, we are not given any specific context, so we do not need a title for our graph, but I am going to give myself a nice straight line that I'm going to work with, and then I'm going to label it. My lowest point is a 59, my highest point is a 69. So 59, 60, 61, 62, 63, 64, 65, 66, 67, 68. We're going to need to extend or move my arrow a little bit, extend the line a little bit. And we have 69. And there's our arrow. All right. So now we're going to plot our dots to correspond with the values. We have one entry of 59. We have 160, 161. We have two 62s, a 63, a 64. We have two 65s. We have a 66. We have two 67s, a 68, and two 69s. All right. Letter D. Again, let's start with a nice number line. And for this one, our lowest value is going to be 0. Our highest value is 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we're going to go ahead and put in our points. We have two values of 0. We have 1, 2, 3, 4, 5 values of 1. Two values of 2. We have two instances of 4. One instance of 5. One of 6. 2 of 7. 3, 8. 4 8s. And 1 9. All right. So now we're going to make a frequency table. So a frequency table, again, we're going to give ranges, and we're going to count how many exist within that range. So I'm going to draw, I'm going to give kind of a box here, and we're going to make two columns. We're going to do one column be the range, and one column is the values within it. So my lowest value is 2. My highest value is 17. So I want to try to have, we're told we're going to do an interval of 4. So I'm going to start with 2. So 2 through 5, right? Because that counts 2, 3, 4, and 5. So that's 4 values. and we've got 6 through 9. We have 10 through 13, and we have 14 through 17. And now we just need to count up. How many do I have in each interval? So how many do I have from 2 to 5? I have 1, 2, 3, 4. How many do I have from 6 through 9? 1, 2, 3, 4. How many do I have from 10 to 13? 1, 2, 3. And how many do I have from 14 to 17? 1, 2, 3. So that is a representation. Could I have used a different interval? Yes, I could have. Could have done an interval of 3. I could have done an interval of 5. I chose 4. One way to kind of help yourself figure out what you're going to do, you do your highest number minus your lowest number and then add 1. So 17 minus 2 is 15. We add 1 to it and it gives us 16 because we need that extra to account for the fact that we are including one of the borders. And so that way, 16, you can easily divide that up into 4 groups of 4. So that's how I settled on 4 for this question. All right. Quiz scores earned by 20 students are listed below. What is a frequency table that represents this data? So we're going to create a frequency table, and we're going to set it up, and we're going to figure out what our intervals are going to be. It doesn't specify what we should use, but I see 10 is my highest, and it looks like 2 is my lowest. So 10 minus 2 is 8, plus 1 is 9. So let's do groups of 3. So 2 through 4, 5 through 7, 8 through 10. Now, if you had done your groupings a little bit differently, that's okay. There is no one absolutely correct answer for this. The thing that you want to pay attention to is you need to make sure that all of your data gets represented, and your intervals should be evenly spaced. So whether you do groups of 3, groups of 4, groups of 5, whatever it may be, make it make sense with the data and make sure they're evenly spaced. So how many are between 2 and 4? 2, 3, and 4. So we have 1, 2, 3 values. How many are between 5 and 7? 1, 2, 3, 4, 5, 6, 7, 8 values. And how many are between 8 and 10? 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Now let's double check. 8 plus 9 is 17, plus 3 is 20. We started with 20 students, so your frequency should add up to the total number of data points that you have. All right, you try problem. We've got data of shoe sizes of a sample of Algebra 1 students from DHS. Create a frequency table that represents the data. Well, my lowest value appears to be a 5, size 5. My highest value is a size 13. 13 minus 5 is 8, plus 1 is 9, so we can do intervals of 3 again. So we're going to do, and you can make your graph a little bigger. So we've got 5 through 7, 8 through 10, 11 to 13. All right, so small feet, 5 to 7. We have how many? We've got 1, 2, 3 people that have 5 through 7. Your average range, 8 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people fall within the 8 to 10 sized range. And then from 11 to 13, 1, 2, 3, 4, 5. All right, so there we go. We have 18 data points. We have 18 in our table. We are good on this problem. So we've represented in a frequency table. Now, our next example asks us to determine an appropriate graph for the data. So letter A, the table shows the number of Olympic medals won by U.S. athletes competing in selected events from the first Summer Olympics in 1896 through the 2012 games. make a graph of the data to show the total medals won for each sport. So is this discrete or is this continuous? This is discrete. Each one of these is an individual thing. There is no connection between them. So this is going to be a bar graph. Now we need to do a little bit of math. We need to find out what is my total number of medals, because that's what I'm asked to graph. So for boxing, we add those up. We've won 111 medals. Swimming, 132. How many of those were just Michael Phelps? Or sorry, diving was 132. Swimming is 520. So Michael Phelps, Katie Ledecky, we've had quite a run over the last couple of years, and this is not even including Katie Ledecky's most recent runs. Track and field, we have 759 medals total, and wrestling, we have 129 medals. So now we need to use this data to make a graph. So we're going to do kind of a coordinate one or quadrant one graph here. So we have, we're going to write our events. So we have boxing, we have diving, and I'm going to just abbreviate. We have swimming, we have track and field, and we have wrestling. And going up our axis, we're going to go 1, 3, 4, 5, 6, 7. And we just need to extend it a little bit and go 8. So we're going to go by 100. So 100, 200, 300, 400, all the way up to 800. Now, these are not going to be perfect graphs, and that's okay. We're just looking for approximate representations. If you want perfect graphs, you're going to have your computer do it. You're going to use Excel or Microsoft Word or Sheets or whatever it is. You're going to use a program to create the perfect graphs. For our purposes, we're going to make approximations. So boxing has 111, so we're going to be just a little bit over 100. Diving has 132, so it's going to be a little bigger than boxing. Swimming, 512, well, that's going to be all the way up to like there. Track and field, 759. So we're going to be all the way up there. I'm just putting in the hash marks because, I don't know, I feel like it makes the graphs look nicer. And then we're back down to wrestling, which is 129. So there we go. We have a representation that is a bar graph that appropriately represents the number of medals the Americans have won in 5 Summer Olympic events. All right. So our next one, we have the results of the top finishers of the 2015 New York City Marathon wheelchair division are given below. Determine whether the data are discrete or continuous and then make a graph. So in this case, the data is continuous. Like it just goes like 1 minute into the next. So this is going to be a histogram. And it's because the data is continuous. So histograms work the same as bar graphs, just they butt up against each other. So I'm going to make my grid, and we're going to do how many entries there were in there. So 1, 3, 5. And I'm going to set my intervals. We're going to do the start times of my intervals. So we're going to have 1:30, so an hour and 30 minutes, an hour and 32 minutes, an hour and 34 minutes, hour 36, hour 38, hour 40, hour 42, and hour 44. So these are the start times of these intervals, and obviously they'll go up to, the first one goes up to 1 hour, 31 minutes, and 59 seconds, right? So it's butting right up against the next one, where the next one starts at exactly 1:32. So in my first interval, that hour 30 to below hour 32, we have two values. So we're going to make a bar that goes up to 2. All right. Our next interval from 132 to 134, there's nothing in between there, so we skip it. The next value I have, we've got 134, 135, and all the way, we're going down there, but then we got to cut it off. So how many values? We have 1, 2, 3, 4, 5 values for this one. Okay. So there's that bar. Now, starting at 136 up to 138, how many do we have? We have 1, 2 more to put in. So we make another bar. And I changed colors just so that you can see how these bars are just right up against each other. And so now we go to a new color. Our next interval is 38 to 40. So I have 38, 39. So that's 4 more. So we go up to 4, and we have that bar. And then we have the next one is 40 to 42. Well, that's just this one. So it's just 1. And our final one is 42 to 44, which is that one right there. And you can see, how when the data intervals or when the intervals butt up against each other, and there's values in each of those categories, the lines just are against one another. Okay, they don't have any gaps. We just run them together. The only reason there's a gap in there is because there was nobody finished between 132 and 134. All right. Bottom of the page are 2 U-Try problems. Go ahead and do those on your own and check your work against mine. All right. The table shows the number of active video game players in each country. Make a graph that best represents the data. So, again, we're going to start. We need to make our grid or piece to work with. So we have that. So we're going to go by, let's go by 20 million. So 20, 40, 60, 80, 1, 20, 40, 60, 80. So I'm not going to label every other, or I'm not going to label everyone. I'm going to just label every other. So, but we are going by 20 million. So that's 140, 180. And we should label some units, and so we're going to say players in millions. Okay. Down below, we're going to list our countries. And so we've got first Australia, we've got Brazil, we've got France, Germany, Italy, Poland, Spain, Turkey, UK, US. And we're going to carry over a little bit into the next column. So Australia has 9.5 million, so that's going to be a little bar, only about halfway up. Don't need to select you. It's going to be a bar like that. Brazil, 40 million. So that's Brazil's bar. France is 25, so similar to Australia. Germany has 38 million, so we're going to be a little taller. Italy has 18, so we're going to be a little shorter if we can. Poland has 11, even smaller. Spain 17, Turkey 21, the UK 33, and then there's the US with 157. So we have 157 million active video game players here in the United States. All right, so now let's look at the table shows users of a photo sharing app by age group, and we want to know what is the graph that best displays the data. So we're going to do this, and we're going to do this. We have our graph. I see that my low end has 1% of users, my high end has 45%. I'm going to go by fives maybe and take it up to 50. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And that is users. And that's a percentage. And down below we have our age. And we're going to go ahead with ranges. We are given that 18 to 24, so I'm going to just use our starting points. 18, 25, we have 35, we have 45, and I'm doing this just for speed and for space considerations. 55, 65 plus. So you can show the full range, 18 to 24. I'm just doing this just because of the space limitations and to go a little faster with getting through these notes. So 18 to 24-year-olds, 45% of users have a photo sharing app. So we're going to take our line up to 45%. There's our bar. And if you want to draw the bar down there, you can. 25 to 34-year-olds, you drop to 26%. 35 to 44-year-olds, we have 13%. 45 to 54-year-olds, we're at 10%. 55 to 64, we're at 6%. And then 65 plus, we could barely register, but it's going to be that. So again, you see how these graphs are butting right up against one another. There's no gap in between. All right, so now interpreting histograms. We've got three different ways that we can describe a histogram that we're seeing. The first one is a symmetric distribution. This is what you might hear of as the classic bell curve. Your data is evenly distributed. You have a few people at the very high end, you have a few people at the very low end. The majority of your people or values or whatever it is are in the middle of your graph. So on a box and whisker plot that we made yesterday, this would be your whiskers are the same length and your median is in the center or very close to the center. And in a dot plot, you'll see the data is evenly distributed. You'll see this kind of shape of going up and down, or even something like this, a reverse, reverse of it. It could be a U-shaped data where you have a lot of high and a lot of very low and not very much in the middle. That would still be a symmetric distribution. So a positively skewed distribution typically has a mean greater than the median. So that just means that your average is higher than where your middle value is, meaning you've got lower numbers. So it is counterintuitive. A positively skewed means we have fewer data on the right. The right whisker is longer than the left whisker. That's why it says positively skewed. You can see how the box is shifted to the right more. And then there's fewer data on the right when it's positively skewed. Conversely, when it's negatively skewed, we can see it most clearly on the box and whisker plot. Your left whisker and the left half of the box are bigger. They're stretched out more because you have a bigger range of values in that end of it. So below, we've got some data on the home runs hit by each batter in the 2023 Home Run Derby. Create a frequency table and a histogram to represent this data. Identify the distribution. So we're going to start with a frequency table because that's what we need to use to do a histogram. We need to start with a frequency table because we need to know how many are in each range. So from 11 to 16, we're going to do 17 through 22, 23 through 28, 29 through 34, and I need one more row, and we're going to do 35 through 40. So in that 11 to 16 range, there is one person. 17 to 22, 1, 2, 3, 4, 5, 6. 23 to 28, 1, 2, 3, 4, 5, 6. In 29 to 34, there is 0. 35 to 40, we have 1. Even though it's at the very start of that interval, we're going to go with 35 to 40. So we're going to make our histogram. So we create a graph. And then we are going to do 11 to 16. We're going to do 17 to 22. We're going to do 23 to 28. We're going to do 29 to 34 and 35 to 40. All right. And we're going to just put some tick marks on here. So the highest value we have is 6. So 1, 2, 3, 4, 5, 6. So in my first box, there's my first bar. In the second box, 17 to 22, we have 6. So we're all the way up to here. In our next one, 23 to 28, still at 6. 29 to 34, none. 35 to 40, 1. So what kind of distribution are we going to see here? This definitely looks closer to that positively skewed one than it does anything. So we're looking at something being positively skewed here. All right, down below, we've got some graphs for us. We just need to determine how are they skewed. So letter B, we are shifted to the left, so that is positively skewed. And that center one, we do see that kind of bell curve distribution that is symmetric. All right, now we're going to go to our last topic of the day, which is a cumulative frequency table. I have given you the tables, and we are just going to represent the values. So we have the number of text messages sent on one day by different students shown below. What is the cumulative frequency table that represents this data? So between 0 and 9 texts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many are at that level and below? We have 11. My next range, 10 to 19. So 1, 2, 3, 3 elements in that one. So now what is my cumulative? We're at 14 at 19 or below. My next range, 20 to 29. 1, 2, 3. We are now up to 17 as our cumulative. 30 to 39. 1, 2. We're up to 19 for our cumulative. And 40 to 49, we've got 2 values, so we're up to 21 for our cumulative. All right, what is the cumulative frequency table that represents the data in letter B? So between 0 and 5, we have 1, 2, 3, 4, 5, 6, 7 values. So our total is 7. Between 6 and 11, 1, 2, 3, 4, 5. My cumulative total is now 12. And then from 12 to 17, 1, 2, 3, 4. So that gives us now a total of 16. And that's all of our values. So you have one last one to try on your own. You're going to check your work against mine. So the ages of people at a family restaurant on one evening are shown below. What is the cumulative frequency that represents the data? So people between the age of 0 and 9, we have 1, 2, 3. Did I miss one? 1, 2, 3, 4, which is a cumulative of 4. Between 10 and 19, 1, 2, 3. And that gives us a cumulative frequency of 7 now. 4 plus 3 is 7. 20 to 29, how many 20-year-olds do we have? 1, 2, 20-somethings. So my cumulative is now up to 9. 30-somethings, we have 1, 2, 3, 4, 5, 6. 6 30-somethings, that brings our total up to 15. Our 40-somethings, 1, 2, 3, 4, 5. We have 5 40-somethings. And our final category, our 50-somethings, 1, 2. And that gives us a total of 22. That brings us to the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.